Okay, all right. So for this question here, sorry, for the sake of the recording, I'll just repeat the first part. In the sequence of trials, the probability in the first trial is 1/2, and then in subsequent trials, it is only 1/2 if it didn't occur in the previous trial. It will be 0 if it did occur in the previous trial. And then in 3 trials, we need to find the probability it occurred exactly twice. So PR x is equals to 2. So 2 out of 3 trials, the event occurred. Now, what are the possible scenarios? So remember, we did binomial distribution before. This is like an advanced version of that, where you need to understand the order of it. So there'll be certain scenarios where if it's 1, then it could be 1, 1, 0, 1, 0, 1, or 0, 1, 1, right? Technically, in our 3 trials, you can get 2 successes in this way, right? Now we need to find out what's the probability of getting 1, 1, and 0. So the chance of getting a 1 in the very first trial is always 1/2, right? Because the probability of the event occurring is 1/2. Alright, I'm giving a bit more space here. What's the chance of it occurring again? What do you think, Stephen? If it occurred in the first, what's the chance of it will occur again? Right, the second trial is independent. Oh, actually, it's not independent.
1 and 2 again then?
No, read this one again.
0, but you can't times it by 0.
No, you can.
Oh.
The chance of it happening again is 0 because if it already happened, it can't happen again. That's what it means.
Oh, okay.
Does that make sense? Right? If it occurred in the previous trial, here, 0 will be the probability that it occurred exactly immediately after. Which means we cannot get the sequence 1, 1. Right? We can't get two events occurring like consecutively. We can't get that. Because and then the third one to get it 0 would just be 1/2, right? Because at any point in time, if it hasn't occurred before, it will be actually it doesn't matter because once you times it by 0, this one will be 0. So there's no chance of this happening. Which means there is no chance of that happening either. Right? Now, what's the chance of this one happening? Probability is equals to 1/2 for the first event, right? And what's the chance of it occurring 0 times in the second trial in that exact order?
It's nothing.
It's not nothing. The chance of it, the chance of the event not occurring is 100%.
Oh yeah, because it's 0 then.
Because it's 0, right? 0 if it did. So it happened before, which means it must be a 0 after. Right? Okay? And then what's the chance of it getting a 1 right after that is 1/2. Therefore, this is 1/4. Exactly twice in 3 trial is 1/4. Okay? So that's A1. Now A2. Exactly twice in 4 trials. Now 4 trials, that means, and remember we learned something new. We learned that we can't have 2 1s consecutively. Right? And because we can't have 2 1s consecutively, now Peter, if you're listening to this recording, if you want, you can pause here and try to do question A2 first and question B as well before listening to my explanation because I'll go straight to the answer. But for me, when I was learning through this, I actually went through a few pathways before I get to the final answer. Okay, so this is a tricky one. So try that out first, but that's okay, Stephen. You can just listen to the explanation and then go back, try to forget about it. And then when you do it again tonight, it will be like, what was it again? And then you do it from scratch. Yeah. You'll get like a vague idea, which is similar to in exam. You get like a vague idea. Oh, remember I did this one with Koi earlier at some point in time, somewhere. So you just got to be able to recall that. Anyway, 4 trials. So 4 trials mean you need to systematically list out all the trials, right? But remember, you can't have 2 1s consecutively, so it must be 1 and then 0, right? And then after that, it must be 1 0 0, or it could be 1 0 and then 0 1 0 1 0 0 0 1, right? Sorry, 4 trials, not 5. So yeah, that's it. So if you start with a success, then you only have these 2 scenarios. Okay? If you start with a failure though, then the next one, you could have a success or you could have a failure. So it could be 0 1 or 0 0. Alright, because remember, the probability of it happening is 1/2 if the first trial didn't occur. If the previous trial didn't occur, right? Which means you could get 0 and 0. Does it make sense?
Yeah.
But you can't get 1 1.
Yeah.
Yeah. So 0 and 0, or just say 0, 1, then the next one must be 0. Then the next one could, in order for it to get 2 trials, must be a 1. Right? The last case though, it will be 1 and then 1. Remember, we can't have consecutive. So this one is actually not acceptable. Alright, so out of 4 trials, these are the only 3 scenarios that could actually happen. Alright, and let's find out the probability of these ones. So, okay, so the chance of you getting a 1 in the first trial is 1/2. And then because you got a 1, the next one must be a 0. Alright, and then for you to get a 1 is another 1/2. And once you got a 1, the next one must be a 0.
Yeah.
Alright, same here. Chance of you getting a 1 is 1/2, and then after that getting a 0 is 1. The chance of you getting a 0 though is 1/2. Right? It's 50-50 whether you get a 0 or 1 if the previous one is a 0. Right? Similarly, it's also a 50-50 if you get a 0 or 1 if the previous one is also 0. Yeah? It's a bit tricky, right? And then this one was the same thing. The chance of you getting 0 first is half, and then the next one is also half. You could get a 0, but you got a 1. But after you got a 1, you must get a 0 over here. And then the last one is either 0 or 1.
Yeah.
So when you time this in, it's just 1/4, and this is 1/8, and this is 1/8. Okay? So the probability, you add them together, so therefore probability that 2 occurs out of 4 would be 1/4. You plus these together, right? Because either case it could occur. That's why it's like the combination thing, where if there are multiple ways of it happening, you need to find how many ways there are and multiply, because it would be the same number and then plus the same number and then plus the same number that many times.
Yeah. Okay.
Yeah, it's like the binomial distribution.
Yeah.
And so in this case, it could happen in 3 different ways, but each of them has a different probability of happening. So you gotta just add them all together. So that'll be 2/8, 1/4, so that'll be 1/2, which is the answer here. Twice in 4 trials is 1/2.
Yeah.
Okay, now, this is the show that, so it's just to help you confirm that your hypothesis is correct. And then question B is a real deal. What is the probability of this event occurring exactly twice in 5 trials? Same thing, twice, but now 5 trials. Okay, now this is a real deal. I'll show you guys the final answer. But remember, same process, because we did that for 4 trials. So we start with 1. 5 trials, right? Could be 0, 1, 0, 0. Because 2 successes, right? Or 1, it must be 0. It can't, remember, you can't have 1, 1.
Yeah.
Right? So it must be 1, 0, and then the last 3 will just permutate. So 0, 1, 0, 1, 0, 0, 0, 1. Okay? So these are the first 3 scenarios, and then if you start with a 0, then the next one, let's say if it's a 1, then it must be a 0, and then so the last 2 digits will just permutate. Right? So you get 1, 0 or 1, 0, 0, 0, 1. So these two are similar together, where we fix the first 2 digits. The first one we fix only the first 1 digit. Okay? Alright? And then after that would be 0, and then assuming the second one is also 0, right? Then how many permutations do we get? Well, the last, in order to get 2, we must get a 1, and then 0, and then 1. That's the only scenario. If we start off with 2 zeros, right? Because you can't get 1, 1, 1, 1, 0 or 0, 1, 1. Okay, so these are the only scenarios. What's the probability of this one? Again, we study the first one is 1/2. The next one must be is a 0, so the probability of that is 1, 100% happening, and then it will be half, and then it will be 1, and then it will be half again.
Yeah.
That makes sense? So every 0 after the 1 has a 100% chance of happening. Right? These 2 zeros has a 100% chance of happening. But then the last 0 though is only 1/2. You could get a 1 again or a 0. Right? So that's a little bit tricky. Same thing here, 1/2 times 1 and then times 1/2. But if it's a 0, that means the next one is also 1/2. But then the last 0 is a 100% chance of happening. Okay, so that one will be 1/2 times 100%, and then 1/2, and then 1/2, and then the last one is also 1/2. So this is a bit strange, right? Because it's like 0, 0, 1. Right? 0, 0, 1 means the first 0 has a chance of 1/2, and then another 0, and then the last one is a 1.
Yeah.
Okay, so that's why this number is a bit strange here. The chance of getting a 0 first is half times by 1/2 to get a 1, and then 100% to get a 0 after, and then half to get a 1, and 100% to get a 0.
Yeah.
Okay, same thing here. 1/2 times 1/2 times 100% to get a 0, and then 1/2 to get this 0 here. This 0 is 1/2. Okay, and then 1/2 again to get the last one. Okay, and the last one is 1/2 times by 1/2, and then exactly 1, and then 1/2 again. Okay, so this is just 1 over something. So essentially you can just count how many 2's and just raise to that power. So the top one is 1, 2, 3 2's, so that's 1 over 8. Okay, and then the next one is 1 over 8, and this is 1 over 16, and this is 1 over 8, and this is 1 over 16, and then this is 1 over 16. Okay, so then the probability of 2 out of 5 trials, right, would be 1 over 8, and then there are 3 of those, plus 1 over 16, and there are also 3 of those. Okay, so that's 3 over 8 plus 3 over 16. Well, that would be 6 over 16 plus 3 is 9 over 16. That's the final answer. Okay?
Yeah.
The tricky, right?
Yeah, a little bit.
So the trickiest part is to understand why. I think there are 2 things. Understand why you can't get 2 1s consecutively, because the chance of you getting the next, like after you get a 1, there's 0 chance of you getting another 1. And then the second thing is you the probability of getting a 0 after a 1 is 100%. Okay, half chance to get the first one, but then the next 0 is 100% because it must be a 0.
Yeah.
Right, but then you can get 0. You can get a sequence like 0 and then 0 and then 1, because it's a it's a half chance to get a 0, and because it was a 0, then the next one is also half a chance to get a 1 or a 0, and then the next one would be half chance to get a 1 or a 0. That's why if it's 0 0 1, then it's half times half times half.
Yeah.
Okay, so yeah, this is like the decision. This is like the spanning tree, the probability tree, but the more advanced version.
Yeah.
Yeah, much more advanced. Okay, so next is, let's see how many of these questions we can go through now. This is a bit tricky. I'll see if I can go through this one in time. Question 9. Very short, very difficult. Katya and Mickey play a game in which a fair 6-sided die is thrown 5 times. Katya will receive $1 from Mickey if there is an odd number of 6's. Alright, odd number of 6's. Mickey will receive X dollar if there is an even number of 6's. Find the value of X so that the game is fair. Note that the number 0 is even. So what? When you throw a 6-sided die thrown 5 times, right? Okay, you could get PR X equals to, and this is the advanced version of binomial distribution. Okay, you gotta understand, when you throw 5 times, you could get 0 6's, or 1 6's, or 2, or 3, or 4, or 5 6's. Right? These numbers are even, and the other numbers are odd. And remember, the probability of each of these is not the same. Right? It's a binomial distribution. Right? It's not the same. Probability of getting a 0 would be 5 0. Well, 0 means it's all non-6's, so that's 5 over 6 to the power 5. Does that make sense?
Yeah.
Yeah. And let's say 4 would be, out of 5, you get 4, and then 1 over 6 to the power 4, 5 over 6 to the power 1.
Yeah.
Right? Yeah. So that is why, if you're working these questions out, write as much as you can. Right? And then at this point, let's think. Katya will receive $1 if there's an odd number of 6's. Right? And Mickey will receive X dollars if there's an even number of 6's. Which means when you add up the probability of, let's say, an even number of 6's and times that by X, you get how much the expected value, the expected income for Mickey. Right? And then you add up the probability for all the odd numbers and times that by 1, you get the income for Katya. Right? So roughly, fair means Katya income, right? Katya expected gain. Katya gain, so remember this, expected of Katya gain must be the same as expected value of Mickey's game. Right?
Yeah.
Okay? Which means this would be 1 times by, well, to write it out, it's going to be a bit long, but it will be PRX equals 1 plus PRX equals 3 plus PRX equals 5, right? Odd numbers of 6s. Yeah? And then that would be X times by PR of X equals 0 plus PR of X equals 2 and then plus PR of X equals 4. Does that make sense?
Yeah.
Yeah? Okay? But get up to that part is the complex and familiar. The rest is just complex familiar. So it's complicated, but it's familiar. You just got to work out what each of these is. There are 6 of them.
Yeah.
Okay? I'll show you guys the algebra here. 1, which means it's going to be, so 1 times anything is just the same thing. So I'll just ignore the brackets. So that would be 5, 1, which is 5. Alright, 5, choose 1, then 5 was choosing 1, and then that would be 1 over 6 to the power 1 times 5 over 6 to the power 4. Right, that's PRX equals 1.
Yeah.
Right, I'll alternate the color so it's a bit easier to see. And then 5 choose 3. Now at this point, I just need to draw out the Pascal's triangle. Can't cheat over here. 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. Okay, and it's easier to write. This is corresponding to 0, 1, 2, 3, 4, 5. All right, so I don't get the wrong permutation combination number. 5 choose 3 is 10. So it'll be 10, and then 1 over 6, 3 successes, so 2 failures.
Yeah.
Okay, and then I'll change it again. Plus PRX equals 5 would be 5 choose 5. There's only one way. There should be 1 there. Yeah, 1 way. So that would be just, oh yeah. So 5 successes would be 1 over 6 to the power 5.
Yeah.
Okay, and that's equals to. I'll keep the x there. So in the brackets, x equals to 0, so no successes. We did that earlier, so that's 5 over 6 to the power 5, right? All failures. And then x equals 2, so that would be 5, 2, that's 10. 1 over 6, 2 successes, 3 failures. Okay? And then plus, change the color. X equals 4, 5 choose 4 is 5. And then that would be 1 over 6 to the power 4. And 5 over 6 to the power 1. Everything times x.
Yeah.
Alright, make sense so far?
Yeah.
Can you do this by hand? You've got to do this by hand, there's no choice. Okay? But remember, there is a trick to do these kinds of questions by hand, right? What's the trick?
Just take out factors.
Take out common factors, yes. Right? So looking at these ones, what are the common factors here? So first, when you see these things, right? Okay, let's simplify first. The top here would be 5 power 5, and this is why you learn index laws, because your life will be a lot easier, and 6 power 5. Yeah. You see, it's always going to be 6 power 5 at the bottom, right? So that would be 10 times by 5 squared, so 10 times 5 squared over 6 power 5, right? For the second term, and the last one is 1 over 6 power 5, right? And they both will be equals to x times by 5 power 5 over 6 power 5. Aha, you see what the common factor is already? 10 times 5 cubed over 6 power 5 plus 5 times 5 over 6 power 5.
Yeah.
Yeah? You take out common factor. 1 over 6 power 5.
Yeah.
Alright? So take out that common factor. In this side would be 25 plus... there's nothing else you can take out, so you got to work it through. 250 plus 1 equals 2, and then you take out 1 over 6 power 5, and then x times by 5 power 5. Oh, that one's trippy. All right, let's leave it for now. Plus 10 times 5 power 3 plus 5 times 5. Make sense?
Yeah.
Yep. Okay, that means that 1 over 6 power 5 can be cancelled off on both sides, divide by the same number. Then the left one would be 276,
yeah,
right? Equals to x times by, okay, now I can take a few common factor out. The first one is 5 squared, right? Take out 5 squared, then this one would be 5 power 3 plus 10 times 5, which is 50, plus 1. Okay, so So then 276 is equals to 25x times by, this one will be 125 plus 51, which is 276 equals to 225x times by 176.
Yeah.
Okay? Again, the trick is when you get to these points, right, do not multiply them straight away. You think of division first. Okay, so I divide both sides by these things here. So I'll get the left hand side 276 over 25 times 176 equals to x.
Yeah.
Right? So look at these numbers. I will test. So first, if I can divide by 2, I straight away divide by 2 because dividing by 2 is the easiest. Right? So 276 divided by 2. 2 by 2 is 1. 7 by 2 is 3. Remainder 1. 16 is 8. Yeah? And then 25 is there. 176, what would be 88? Right? You see that? Equals x. See, I'm still not multiplying the 25 in yet. Right? Just be patient. Keep simplifying first. So 8 and 8, that means I can divide by 4. So divide by 4. 13 divided by 4 is 3. Oh, wait, can I? 38. Oh, no. Sorry. Divide by 2. So that will be 6. Remainder 1. 69 over 25 times 44. Right? Well, can I keep going? I don't think I can keep going. That's about it. Right? Equals to x. So now I just gotta work through that. Which is... Hang on. What question is this? Question 9. Oh, yeah. Yeah. So 69 over 25 times 44 is... yeah, it's gotta work through that. So... Oh, actually, the bottom can split into 4 times 11 times 25. 4 times 25 is 100. Times 11 is 1100. So 69 over 1100 equals x. Right? That's tech-free. Okay? However, if this is tech-active, when you get up to this point, you end solve it.
Yeah.
Okay? When you get up to like this point here, you end solve it. Okay? So this is the tech-free version. Tech-active, you end solve. Okay? Or solve n, I think. Solve n in your calculator. Solve n, and then you get x equals whatever. So the answer would be 0.77. Okay, let me double check. 69 over 1100 is wrong. It should be 0.77. So I don't know. One of these numbers are wrong. So challenge for you guys, go back and see if any of these numbers any of these steps are correct, are wrong. Again, these questions would be a bit unfair to do tech-free, but I'm just using this question to show you guys how you approach like a big calculation like that in a non-tech environment.
Yeah.
Right? But I don't think they'll give you this one tech-free.
No,
it's a bit too mean.
not.
Yeah, they will, as long as you get up to this point, that's pretty good.
Yeah.
Then and so get the answer. Yeah. Or you just punch the left in, punch the right in, and then divide.
Yeah.
Simple stuff.
Yeah.
Okay. So yeah, so that's the main idea for this question here. That's wrong. Don't rely on that number. Okay. Now this one is one of those where it also requires a little bit of thinking. If you guys did any kind of scholarship tests in the past in like primary school and stuff, they would have this kind of pattern recognition here. And if you want to go to medical, they do a lot of pattern recognition, type questions. Not exactly math related, but it's pattern recognition. So let's see. X is 1, 2, 3, 4, 5, 6, right? Which means you can't use the PDF. You actually have to use the table. So X, and then PR, X equals X. Okay? So there's only a few values, 1, 2, 3, 4, 5, 6. So I need to recognize to make the table. Right? C, we don't know. So that will be C, and then X is 1. So C over 1, C over 2, C over 3, C over 4, C over 5, C over 6. Right? Find the value of C. How do we find the value of C?
You 1 times that?
No. This is still a probability function. It's not a density function, it's a probability function. So total area still equals 1. Remember, this idea is one of the very common ideas when you're doing probability, right? When you have an equation like that. It's very common. if there is a variable in there, you think total area equals 1. That's the only thing that is assumed for probability functions. All right, so you have to remember these ones. So total area equals 1, that means when you add up all the probability, it must be equals 1.
Yeah.
Right? How do we add them up? So C over 1 plus C over 2 plus ... plus C over 6 equals 1. How do we add them up? Well, the trick is grade 5, lowest common multiple. You need to make the denominators the same. Right? So what's the lowest common multiple of 2, 3, 4, 5, and 6? Well, 2 is 2, 3 is 3, 4 is 2 squared, 5 is 5, and 6 is 2 times 3. So then the LCM, the lowest common multiple of all of this, you take all the numbers to a highest power and multiply together. So that'll be 2 squared times 3 times 5.
Yeah.
Right? Because the 2 times 3 already cover for 6, so we don't actually need to do 2 times it again. So you take each of the prime factor raised to the highest power. Yeah. Right? You need to make sure you cover for, let's say 2 squared is to cover for 4 here. Okay? So yeah, that's the lowest common multiple. So that would be 4 times 3 times 5, 12 times 5, 60 is the lowest common multiple for all of these. Right? Now, because they will always be over 60, that means I know the answer is going to be something over 60. Right? How do we get 60 from C over 1? Well, it's 60C, right? How do we get 6? This one will be 30C. You see the pattern?
Yeah. 15.
Yeah. Plus, and then, yeah, that would be 20C, because C over 3 to get 60. To get 60 from 4 is times 15. So 15C over 4, and then plus 12C over 60 plus 10C over 60 equals 1.
Yeah. Okay?
So then add all the numbers in the top up, right? Would be equals to, you times the 60 over, that would be equals to 60, right? Okay, so I'll write equals to 60 here. And you gotta go 60. Now, looking at this one, the easiest way is to try to find 100. 60, 30, 10, 100. Right? So we 100 and then plus the other numbers, which is 20, 15 is 35, plus 12 is 47. So 147 equals 60. So C is 60 over 147. Can we simplify? I don't think so. 7 plus, or actually maybe you can. 1 plus 4 is 5 plus 7 is 12. So you can divide by 3. So that's 20. Divide that number by 3 is 4, 27, 9. 20 over 49. Yep, that's it. So that's C, 20 over 49.
Yeah.
Okay. And then the expected value of x is just once you've got this table, the rest is easy, right?
Yeah, it's 1 times that.
It's just 1 times that, 2 times that, and what do you think is the expected value?
Off the top of my head.
Yeah, what do you think is the pattern here? See.
1 times whatever the C value is. Times 2 times whatever the C value is.
Not times the C value, times the probability.
What do you mean? You just gotta do it.
It's x times probability of, right? So it's that times that, which is
whatever C is.
Yep, and then this times this, which is
2 lots of C.
Not right. 2 times C over 2.
Oh, yeah.
It's just whatever C is. Same here. That's just whatever C is.
Oh, yeah, because then the 3 just cancels.
It's just cancelled
so
out.
It's just 6 times 6.
That's right. So question B, the expected value of x would just be 6 times C.
Yeah.
Okay, the answer would look like that. Right? You can show the other one, but you gotta at some point get to 6 times C. So 6 times 20 over 49, which is expected value, 120 over 49. Done.
That makes sense.
Right?
Yeah.
And then now the next one though, variance, you need to find E of x squared. Right? In this case, we need to square that and times into it. But remember, when you square this and times into that, one of them get cancelled out.
Yeah.
So it's just 2C.
Yeah.
So it should be 1C plus 2C plus 3C plus 4C plus 5C plus 6C. Does that make sense?
Yeah.
Yeah. So that one, to simplify it, don't have to write too much. It will be C plus 2C plus 3C plus that plus 6C.
Yeah.
And remember, you need to like minus the other one squared, kind of thing. Okay. So that's why if you don't actually use the C value first, you can find patterns a bit more easily. Right, so 1 plus 2 plus 3, again, find 10. 4, 6, 10, 2, 3, 5, 10, so that's 21. C.
Yeah.
Okay? 21C, and C is one, which is 21 times 120 over 49. So again, cancel out, divide by 7. That would be 7. And then, yep, that's it. So that'll be 360 over 7. All right. So then var of x would be 360 over 7 minus the mean squared, which is 120 over 49, everything squared. So again, you can, I think this is probably a calculator question. No, it's not calculator question. The answer is a fraction. It's not calculator question. They don't ask you for standard deviation. If you ask for standard deviation, then you have to square root. So that will be a calculator. But this one non-calculator.
120 squared.
Yeah, it's 120 times 120. 12 times 12, 144. And then add 2 0.
Oh, true. So that's actually...
They change the number up so that it's, it's kind of like that, right? 14400, and then that's 7 squared, and then squared again 7 power 4. Which means on the left hand side, you only need to do this and then times by 7 power 3. Does it make sense? And then you get 7 power 4 at the bottom. Yeah. Right? So of course, you got to do 7 power 4, which is 49 by 49 to get the bottom one. Right? Actually, I'll do 49 times by 7 first to get 7 power 3. So 63 and then 28, 34, 343. Okay, and then times by another 7 is 21. 2, 28, 0, 2, 22, 23. So 2, 3 over 2, 3, 0, 1. That will be the bottom. That's 7 power 4. And then 7 power 3 is 3, 4, 3. We got that already. So I'll do 3, 4, 3 and 360. Come on. Everyone knows how to multiply, right? That's why they can ask these questions. 8 remainder 1. So 24, 5 remainder 2, 18, 20. 3, 3, 9, 12, 1, 0. So that will be 0, 8, 4, 2, 2, 1. Right? Getting close there? Yeah. Wait, hang on.
Maybe 3. 1, 2, 3.
Right, I think I lined them up. So it's 0, 6, 1000, 12.
Maybe 3 there, where that 2 is.
2, 3, 0.
1, 2, 3, 4, 8, 0.
Wait, which one?
1, 2, 3, 4, 8, 0.
Yeah, 1, 2, 3, 4, 8, 0.
Because it's 9 then, bang.
Yeah. Okay. 1, 2, 3, 4, 8, 0, and then minus 1, 4, 4, 0, 0 over. Is that 49 by 49? Alright, let's double check. 81, and then 36, 44, 36. So 3, 16, 19, 1, 0, 4. Oh, 2401. How do you get 2301? 6, 34. Yeah. Ah, it's 30. That's right. Add another 1 here. Okay. Yeah, so 2401. 2401. And then the top number minus the bottom number. Wait, I think I lined them up wrongly because the number is looking way too big. 360 over 7. Oh, right, I used the wrong one. C is just 20. Yeah, why did I use 120? Looks weird. Yeah, that'll be 60 over 7. My bad. So it'll be that. Which means it's just that. Yep. 20580. Yeah, so when you see the numbers are way too different from each other, something is wrong. Okay? So yeah, do that subtraction. Once again, it's subtraction. 14400, subtract that. 0816 6180 over 2401. Because the 2401 is 7 power 4. There's no way you can simplify this. Yeah, that's it. 6180 over that.
Holy, that'd be no calculator.
Sweaty, right? With no calculator.
Yes.
Yeah, that's it. Yeah. It's gonna go back and retry these questions. So we did all Nancy all the way to question 12. Question 10.
Yeah.
Okay, there's only 8 questions left. Yeah, there's still 8 questions left. So we'll probably go through them next week. Okay, so please go back if you haven't completed it. 19A, everything, and 19B, everything.
Yeah.
And these ones. Okay, so after next week, you guys can actually get to do 19D, which is the what do you call it? The degree of difficulty classified question.
Yeah,
So
yeah.
SF and then CF and then CU. Yeah. And then you can actually go back. But I think after I finish 19C, I'll leave you guys to do 19D by yourself. I think you guys can do that.
Yeah.
And I'll jump around the harder questions from the previous chapters.
Okay.
Yeah, the one that are in the chapters, like the 3D plane, inclined plane, all that stuff, just in case it comes out.
Yeah.
Okay?
All right.
Cool. That's it.